Did you have a chance to practice? If not, go ahead and pause the video so you can sort these 7 items into either acid, base, or neutral. Okay, let's go ahead and take a look. I'm sorting my acids are going to be on the left-hand side. All of the things that fell under the category acids will be on the left, and bases, which remember is also called alkaline, will be on the right. So first one, any substance with a pH of 11 is definitely a base. Remember, 7 is neutral. Anything above 7 is going to be basic or alkaline. Magnesium hydroxide is something, I'm hoping you see that hydroxide and start to think base. You see these OH groups, that's hydroxide. If you put this into water, it's going to release those, or those will dissociate, and hydroxide ions are one defining characteristic of bases. Acids usually tend to taste sour. Think about vinegar or citrus fruits. So acids are going to be sour, and anything with a pH of 6 is going to be acidic. It's less than 7, it is an acid. The definition of an acid is something that produces or releases hydrogen ions in solution. So something with a lot of hydrogen ions is likely going to be an acid. And conversely, something that takes away or removes hydrogen ions from a solution is going to act as a base because it's going to remove those away. I was hoping that you would take a look at HF and maybe think, it's kind of like HCl, or you'd see that, okay, this is polar because fluorine's the most electronegative atom on the periodic table. This will dissolve, and when it does, hydrogen ion will dissociate, and that will be something that's acidic because it's producing hydrogen ions. Okay, how'd you do? So what is pH? We've been talking about it as a scale, and we can use paper and cabbage to indicate it, but what actually does it mean? What does it stand for? Well, I like to think of it as the potential or the power of hydrogen. Because remember, acids are defined as substances that produce hydrogen ions. And so pH is a measurement, a way of measuring the hydrogen ion concentration in a solution. How many hydrogen ions are in there and how crowded are they? So just as a review, a hydrogen ion is a hydrogen atom that has lost an electron. And as a result, all it really is a proton, because all hydrogen an atom was a proton and an electron. And as a review for concentration, remember, that's how crowded the molecules are. So if we're talking about hydrogen ions, here there's only 2 in the beaker. So that's a lower concentration than over here, much higher. And we use a unit for this is a capital M for molarity. It represents moles per liter. How many moles of hydrogen are dissolved in a whole liter of water? The last thing to know about the pH scale is that it is an inverse logarithmic scale going from 0 to 14. Now, don't freak out, because I know that seems a little archaic, but we can interpret this. The inverse part means as the hydrogen ion concentration increases, the pH actually goes down, right? So something that has more hydrogen ions is more acidic, but it has a lower pH. That's the inverse part. The logarithmic part means that each step on this scale is a change in 10 times the amount of hydrogen ions. So let's try a little practice. Here you have 3 models of solutions. One is acidic, one is basic, and one is neutral. What do you think?